Dear colleagues, we bring to your attention the report, Application of the Geophysical Method of NPEMFE for the Preliminary Geological Outline of Deposits of Technological Iron containing raw materials. At the end of the last century, the intensive development of a new geophysical direction of studying the engineering geological state of the rock massif by the method of recording the natural pulsed electromagnetic field of the Earth, NPEMFE, began. The named method covers a wide range of research, provides the possibility of operational evaluation, control and forecasting of the engineering and geological state of the rock mass under investigation, analyzing the development and current level of application of this geophysical method. It becomes possible to note that the named method is a modern mobile means of studying the engineering geological state of the rock massif. It is justified for crystalline and sedimentary rocks, including mineral exploration. However, electromagnetic emission has not yet been studied in technogenic rock massifs. Over the past 50 years, hundreds of millions of tons of iron-containing tailings have been accumulated at the mining enterprises of the Kryvyi Rih Basin with formed tailings. Extraction and processing of this raw material allows to increase the industrial raw material base, as well as to reduce the resource and energy costs of mining enterprises when obtaining marketable products. At present, the known technologies of geological contouring of man-made deposits of raw materials require the implementation of large volumes of destructive contact and energy-consuming geological exploration drilling works. Based on this, there is an urgent problem of quickly finding a solution to the specified problem. The purpose of the work is to justify the technological and technical possibility of using the NPEMFE geophysical method for the preliminary geological contouring of deposits of man-made iron-containing raw materials, reducing the amount of manual labor and costly drilling geological exploration works. To determine in detail the possibility of using this method, experimental studies were conducted at a specially created landfill. According to the results of landfill research, the technological and technical expediency of using the described method for the preliminary geological contouring of man-made deposits of iron-containing raw materials in lying tailings storage facilities has been established. It was determined that the measurement of the intensity of the signal must be carried out simultaneously in three mutually perpendicular directions: longitudinal, transverse and vertical, on a square grid with an observation step equal to 5 to 25 meters, in the frequency range equal to 0.1 to 50 kHz, according to changes in the intensity of the signal. Both the presence and the position of various engineering geological centers are determined, according to which the previous geological contouring of man-made deposits of iron-containing raw materials. In order to confirm the effectiveness of the improved technological and technical elements of the application of this geophysical method for the preliminary geological contouring of man-made tailings deposits, appropriate field studies were conducted using the geophysical profiling method with the above parameters. The application of the proposed technological and technical solutions is explained in Figure 1 and 2. Industrial tests of the use of the NPEMFE geophysical method for the preliminary geological contouring of man-made deposits of iron-containing raw materials were conducted in Kryubas during geophysical studies of the geological state of the rock massif of the tailings storage facility of the Gigant Hoboka mining factory. The total storage area is 210 hectares. A total of 1145 measurements were made. Processing of measurement results was carried out using appropriate software. It was established that 5 man-made deposits were discovered in the tailings depository of the Hoboka Giant mine. Thus, a preliminary geological contouring of man-made iron-containing raw material deposits was carried out in the rock massif of the specified tailings repository. This allows for a 25 to 30% reduction in the costs of drilling exploratory wells. Thanks to the fact that after performing a set of measurements of the signal intensity level of the NPEMFE, it becomes possible to obtain specific data for the formed storage of iron-bearing lying tailings, in the conditions of a long-term period after the end of the process of its formation, equal to several to tens of years, and to detail the grid of geological exploration drilling. This will allow us to achieve an increase in iron ore raw materials reserves with safe working conditions for mining personnel and the expansion of the area of application development of highly efficient resource and energy-saving technology. The results of the conducted research indicate the effectiveness of the application of the geophysical method of registration of the NPEMFE for the preliminary geological contouring of deposits of man-made iron-containing raw materials in the tailings storage facilities of the Cryubas mining enterprises. Application of these methods improvements will provide an opportunity to increase the efficiency of the formation of a database on the geological condition of the rock massif of the lying tailings storage. At the same time, to determine in the rock mass of the storage not only the disturbance and tension of the state of the rock mass, but also the geological zones that are concentrators of man-made industrial iron-containing raw materials. Optimization of the further technology of geological exploration drilling and development of man-made iron-containing raw materials.